Welcome to the Mawson Mechanical Training Series. Today you will learn about the important principles regarding ladder safety. We will strive to provide information that will increase your knowledge and make you a better and safer worker. The following is a list of OSHA's top 10 most frequent cited standards. OSHA publishes this list as a means of alerting the industry about these commonly cited standards. The hope then that is when you take whatever steps necessary to both find and fix recognized hazards before they become a problem. Look at where ladders fall on this list, and then where scaffolding and fall protection are. Clearly there's a problem heeding the rules in place. Number 1 is fall protection. Number 2 is HAZCOM. 3 is scaffolding. 4 is respiratory protection. 5 is lockout tagout. 6 is powered industrial trucks. 7 is ladders. 8 is electrical wiring methods. 9 is machine guarding. And 10 is electrical general requirements. These are some of the main standards concerning the safe use of ladders. Many industries have additional standards, as do some states. It is your responsibility to know all federal, state, and local company rules that apply to your equipment and job site. Training. No matter the equipment, it is common to hear workers and even employers ask, where does the state operators need to be trained? Can an operator also be deemed qualified based on experience? 29 CFR 1926.21b2, the employer responsibility section on safety training and education for the construction industry states that the employer shall instruct each employee in the recognition and avoidance of unsafe conditions and the regulations applicable to his work environment to control or eliminate any hazards or other exposures to illness or injury. Ultimately, in the case of an accident, OSHA will want to see proof of training. If you cannot furnish that proof and can instead only offer up that the worker came into the job with 20 years of experience, you will most likely be in trouble. Experience may qualify an operator, but very rarely will experience alone suffice. A history of operating for any given amount of time does not necessarily mean the operator knows how to operate safely and competently. So there's just no getting around that one fact. Every worker must receive training prior to using ladders on their own. Requirements for refresher training are also very specific. Regulations specify that an operator must take a refresher course if any of the following apply. The operator is observed operating the equipment in an unsafe manner. The operator is involved in an accident or a near miss. The operator received a poor evaluation for performance. The operator is required to use a different type of equipment or attachment. Workplace conditions have changed. Additionally, regulations state that it is the employer who is responsible to determine the frequency of refresher training. It's important to note the last two conditions for refresher training. This term, type, also causes a lot of confusion, especially because ladder types can be harder to differentiate due to how similar they function. Generally speaking, though, by type, OSHA means portable ladders versus fixed ladders versus A-frame versus non-self-supporting, etc. OSHA standards also says that each operator must be reevaluated regularly to see if they are still competent to work on the equipment. 3 years, if not sooner, is a common time frame used. A so-called free pass cannot be awarded based on experience, age, or time on the job. The extent of the evaluation is to be determined by the employer, but should include a written and practical examination that prove continued competency. Generally speaking, all workers share in the responsibility to ensure that they and their coworkers have received training by a qualified person, read and understood the manufacturer's operating instructions and safety rules as found in the operator's manual, read and understood all decals, warnings, and capacity plates on the equipment and attachments, performed a thorough pre-shift inspection each day prior to operating the machine. Ladder styles. We will be going over 3 different types of ladders: portable self-supporting ladders, portable non-self-supporting ladders, and fixed ladders, including job-made wooden ones. No matter the type, it is important that you use the right ladder for the right application. It is equally important that you are aware of and heed the load capacities for the ladders you will be using. When considering the capacity, you should include not only the weight of the person ascending the ladder, but also any tools and protective equipment on that person. Here is a chart showing the general classifications for all portable ladders. Portable ladders. Because portable ladders can be moved easily, they are conveniently used in many different job sites and situations. As alluded to, there are 2 different classifications of portable ladders: self-supporting and non-self-supporting. Self-supporting ladders, also called step ladders or A-frames, because of the A shape they make when they are set up, are characterized by their ability to stand on their own without being set against or supported by another object. They are typically made of aluminum, fiberglass, or wood. These are some of the main components of an A-frame ladder. Because safety in ladders starts with understanding its anatomy, you should be familiar with the purpose of each component and know how to properly inspect and use them. Non-self-supporting ladders. In contrast to A-frame ladders, non-self-supporting ladders do not support themselves and cannot stand on their own without something on which to lean. Typically, ladders of this classification are taller and have extension capabilities, which allow workers to reach greater heights. They are typically made from aluminum or fiberglass. Non-self-supporting ladders can be a little more complex than your typical step ladder. This is even more reason to be familiar with the various working components, know what to look for when inspecting them pre-shift, and know how to use them safely. If you aren't quite sure about something in particular, take the time to ask someone who does. Asking for such training may feel embarrassing, but a little embarrassment in the beginning is much better than an accident in the end. Fixed ladder. Fixed ladders are, as the name implies, fixed, meaning they are permanently secured to a structure or a building. They are typically seen descending into confined spaces or climbing up silos toward roofs on apartment buildings and into treatment plants or other industrial structures. Even with these ladders, you need to know of their makeup and how to inspect them. The rungs, of course, are common from ladder to ladder, but other than that, fixed ladders can differ greatly, and it is vital you are equally familiar with their components, such as extensions, the cage or well, rest platforms, and lifelines. Job-made wooden ladders. Job-made wooden ladders are temporary fixed ladders built at a specific job site in order to provide access to evaluated work areas. These are typically used until the job is complete or a more permanent solution is provided. When built and used correctly, they can be an easy and safe way to avoid using multiple portable ladders and all that entails. For the sake of better understanding their various components, let's quickly discuss the steps to building one. First, make sure that you use construction-grade lumber or another non-conductive material. When building a standard 24-foot single-cleat ladder, the side rails should be made with 2x6 non-animal stock lumber. The side rails should also be continuous unless splices are the same strength as a continuous rail of equal length. Be sure your rails are spaced 16 to 20 inches apart from inside to inside. The rails should also be long enough so that they extend 36 to 42 inches above the top railing without rungs between the rails, thus allowing for a way to safely dismount. For 16 to 24-foot ladders, you should use at least 1x4 wood for the rungs or cleats, and they should be spaced 12 inches apart from top to top. 12D wired nails should be used to fasten the cleats directly to the smallest side of the rail, as seen in the picture to the right. Do not cut the side rails in order to receive the cleats. Once the cleats are in place, filler blocks should be placed between them to make them more sturdy. When inserting fillers, start at the bottom and work your way to the top using 12D wire nails spaced 1.5 inches apart. Pre-shipped inspections. Ladder inspections. No matter the type, all ladders designated for use need to be inspected. You should inspect them when you first buy it to ensure it is in good working order. Make sure they have applicable OSHA and ANSI and UL seals of approval. Additionally, according to standards, your ladder should be inspected again each day before use. This is often referred to as a pre-shipped inspection. These inspections should be more formal than just a quick glance over. Because ladders are used day in and day out, it is common to see workers avoid or lessen the extent of their pre-shipped inspection duties, assuming that if it was okay yesterday, it will still be okay today. But this is just not true. In fact, it is a dangerous line of thinking. Components can weaken on any given day, especially when used in rough conditions. Foregoing your daily inspection could result in you missing signs of immediate failure. As part of the formality, you should use an inspection booklet or checklist to properly document the inspection, any signs of damage discovered during it, and any required actions you will take to ensure the ladders are safe for use prior to someone working on them. Oftentimes, this type of checklist is provided by the ladder manufacturer. These inspections and maintenance record should be kept on hand for possible future reference. As far as damage goes, if your inspection uncovers damaged components that might prove hazardous, the ladder should be tagged or locked out and removed from use until it can be fixed or replaced. Any fixes must only be done with authorization from the manufacturer and in a way that will restore the ladder to its original rated capacities. Otherwise, it must be permanently removed from use. Never use a ladder in need of repair. Portable ladder inspection. Let's first look at inspection of portable ladders. Ladders are ladders, true, but the different materials can be prone to certain types of damage. Add to that the fact that ladder types and components can differ greatly when comparing A-frames to extension ladders to specialty ones. Again, this is why you should always consult the manufacturer safety manual prior to inspecting your ladder. Labels. Make sure that all warning labels or markings are in place, clean and clear, and legible. They may seem like an insignificant component, but they are required for a reason, to remind you of safety principles and to ensure that no excuse for bad behavior. If you have to replace the label due to damage, deterioration, or fading, contact the manufacturer to get the correct one for your ladder type and place it in the same location. Structure. Aside from labels, You are looking for anything that might compromise the structural stability and integrity of the ladder. For step ladders and A-frames, pay particular attention to the following: to the steps, the rungs, the rails, the pail shelf, the top, the spreader bars, the bracing, the shoes, and the rivets. It doesn't matter if the ladder is made of aluminum, fiberglass, or wood. Take the time to look for and report anything that is loose, cracked, bent, missing, frayed, splintered, worn out, or damaged in any other way. Note any sharp edges, points, or edges. And as mentioned previously, don't forget to address any areas showing excessive rust, corrosion, or dirt or grime. Fixed ladder inspections. As in the case with portable ladders, when it comes to any type of fixed ladder, you're basically looking for same issues: broken side rails, broken, missing, or worn steps, rungs or cleats, damaged cages, guardrails, other fall protection, loose fastenings, or damage to the wall. You should also pay close attention to areas where welding has taken place, looking specifically for structural cracks. This is one reason you should never paint your ladder. Paint can easily hide defects and cracks and lead to a surprise failure. Recently, an entire crane came crashing down. Upon further investigation, it was discovered that there had been some significant cracks at the base of the pedestal. Those cracks, however, were painted over. With a fresh coat of paint, everything looked fine, but those cracks continued to spread underneath the pedestal until everything came crashing down. Fixed ladder slope. There are certain requirements that govern the slope of a fixed ladder. More specifically, the slope should be between 75 and 90 degrees. Slopes greater than 90 degrees are prohibited. Clearance. All fixed ladders require clearance so as to not be hindered by surrounding objects. This is especially important when safety cages, also called basket guards, are present. If the fixed ladder does not have a cage surrounding it, there should be at least 15 inches of clearance in every direction from the center line of the rungs. However, perpendicular clearance increases in accordance with the slope. For instance, if the slope is 76 degrees or 90 degrees, then the perpendicular clearance should be 36 degrees or 30 degrees, respectively. Fixed ladder cages. Any fixed ladder between the length of 20 and 30 feet are required to have a cage around them. Safety cages must start 7 to 8 feet above the base of the ladder and extend at least 42 inches above the landing area at the top of the ladder. Note, the 42-inch extension is the same requirement by OSHA for guardrails, but is more than the 3 feet a portable ladder needs to extend above a landing. Landing platforms. When a fixed ladder exceeds a height of 20 feet, landing platforms need to be provided for every additional 30-foot section. However, if there are no cages on the ladder due to an exemption, then platforms must be provided every 20 feet. Moreover, if the worker on the ladder has to step farther than 12 inches off of the ladder to reach a nearby structure or piece of equipment, then a landing platform must be provided, and the minimum step across distance of the platform should be no more than 2.5 inches. Safe operations. Choosing a ladder. Consider the following acronym: CLIMB. C. Choose the right ladder. L. Look for damaged or missing parts. I. Ensure yourself by choosing a stable setup. N. Move carefully using 3 points of contact. And B. Be a safety expert, not a statistic. Choosing the right ladder for the job is where it all starts. Each ladder has a different qualities. Self-supporting ladders may not give you the height you need, but non-self-supporting ladders may not give you the needed stability or versatility. So how do you determine which one to choose? Think about the worksite and the job you will be performing. Then ask yourself specific questions related to its intended use, like these. Where will the ladder be used? What is the nature of the job? What will the job site look like? How high is the project? How much weight will be put on the ladder? Are you going to be around electricity or obstacles or hazards? Inspection. Conduct a thorough pre-shift inspection. These inspections and any completed maintenance should be properly recorded. As part of your inspection, make sure all the required warning labels and markings are on the ladder and in a legible condition. Follow the warnings and replace them if they're damaged or cannot be clearly read. Never exceed the maximum load rate for the ladder you are using. Keep in mind that this capacity is not just your weight, but includes any tools, supplies that you have with you on the ladder. So if you weigh 220 pounds and you have another 10 pounds of tools with you, you're over capacity and will need a ladder with a larger capacity. 3-point contact. When ascending, descending, and working on a ladder, you should maintain a 3-point contact. That means 2 hands and 1 foot, or 1 hand and 2 feet. This applies to mounting and dismounting as well. Avoid leaning too far to one side or too far back, nor should you step off of or around the ladder without proper avenues for egress. Doing so could easily upset your balance, causing you to fall or the ladder to tip over. Instead, remain close and centered. The belt buckle rule is generally a good way to gauge safe parameters. Always keep your belt buckles between the side rails of the ladder. Even then, though, you should always be careful when leaning or reaching any distance away from the center of the ladder. Similarly, do not extend your reach by standing on the top of the ladder or any unauthorized rungs. Typically, the top 2 rungs on a step ladder, the top 4 rungs on an extension ladder are off limits. If you cannot reach your desired work spot without standing on those rungs or your tiptoes, then you need to take time to get a longer ladder or an extension. The same goes for trying to extend your reach in other ways, like by placing the ladder in an unauthorized platform, such as a scissor lift or a bucket of a loader or other machinery. Don't do it. As mentioned before, most non-self-supporting portable ladders are capable of receiving extensions, but they must be approved by the ladder manufacturer, and you should receive training regarding attaching them correctly. In no situation should you ever weld or attach your own jury-rigged extension. Use a ladder in accordance with their intended use. It is common for workers to need 2 or 3 different types of ladders during a single shift. Unfortunately, it is also common to see them just justifying using the one ladder multiple ways, rather than taking the time to get 3 ladders designed specifically for those ways. Never reconfigure the ladder to make it work in a manner other than its intended purpose. Some ladders are designed and rated to be set upon like scaffolding, with a platform stretched from one end to the other. If you need to use your ladder in such a way, make sure it's first approved for this by the manufacturer. The platform and other components also need to be approved by the manufacturer of the ladder itself. Also, take the time to consult the instruction booklet before setup. Avoid steep angles and soft soils, as it can be easily collapsed. Do not straddle 2 ladders simultaneously. Keep both feet firmly planted on the rungs of the ladder when working, and never allow more than 1 person at a time on it. Doing the ladder is sure to exceed the duty rating and can cause the other worker to become unstable. The ground on which you intend to set up the ladder should be thoroughly inspected prior to placing the ladder. Whether in a warehouse, on a vessel, or on a construction site, The ground should be level, stable enough to hold the weight of the ladder and worker, and free from rocks or other debris that could cause tip over. Be wary of soft soils, especially in inclement weather. A non-self-supporting ladder should be set up at a 75-degree angle from the ground. An easy way to check this is to stand at the base of the ladder. Then bring your arms up perpendicular to the rung at shoulder height. The palms of your hands should be able to just rest on the rung in front of you. If you can do this, then in most cases, the angle is set up correctly. Traffic and barricades. If you're working in an area with high foot or vehicle traffic, you should set up barricades, warning signs, and other precautions. Because wind, people, traffic, etc. can easily upset barricades. It is equally important that you maintain these as needed throughout the day, so no unauthorized bystanders or workers enter the work zone. Pedestrians have the right of way, but ultimately it is your responsibility to be aware on foot of your workplace. Keeping tools in a tool belt will not only free up your hands for climbing, it will keep the tools more secure and less likely to fall. Tool lanyards, too, can prevent them from falling. If the items are too heavy or bulky, create a pulley system that will allow your tools to be carried up to you with a rope and a bucket. Never balance your tools on the rungs. Common hazards. In spite of their simplicity, ladders can be a very dangerous piece of equipment, and most of the injuries and deaths surrounding them are due to several basic hazards. At the top of the list, statistics show that in the last decade, 43% of fatal falls involved ladders. In this section, we will discuss some of the more common hazards associated with ladder use and show you how to recognize these hazards and avoid or minimize them. More specifically, we will look at falls from heights, dropped falling objects, and electrocution. Case study number 1. Employee number 1 was fixing the roof of a building. The building was 2 stories high, but he only had a 16-foot ladder. The ladder was 2 feet too short of the height of the roof, but sat squarely against the building. Employee number 1 used the ladder anyway, stepping onto the top rung to reach the roof. As he did, however, the ladder shifted beneath him, causing him to lose his balance. Employee number 1 fell the 2 stories and landed on the ground. He was transported to the hospital, where he died from injuries sustained in the fall. Clearly, the size of the ladder was inappropriate for the height of the job. Too often, workers do not take a few minutes needed to find the right ladder. In this case, the ladder was too short, and he chose to use the top rungs instead. Remember, you should never stand on the top rung, and when using a non-self-supporting ladder, it must exceed 3 feet above the landing area. Additionally, it is worth noting that employee number 1 did not secure his ladder in any way, nor was there anyone there to help support or stabilize the ladder. It is important and necessary to secure the tie-off non-self-supporting ladders, especially when using them alone. Asking a coworker to act as a spotter to help stabilize the base of the ladder is another great idea when ascending and descending ladders. This is especially true when working in inclement weather. Considering the following accident. Case study number 2. Employee number 1, the father in a small father-son window washing company, was up 40 feet on an extension ladder, cleaning windows. The weather outside was sunny, with the occasional strong gust of wind. At one point, employee number 1 took both hands off the ladder to adjust his work belt. During this time, the wind picked up. It is estimated to be 25 miles an hour. Employee number 1 lost his footing, fell backwards to his death, landing just feet away from his son on an A-frame ladder, washing the lower windows. There is a saying in the industry, the rain will drive you crazy, but the wind will kill you. In this case, it proved true. This is a tragic accident that is easy to blame on nature, but the reality is, employee number 1 should not have been up that high with the wind gusts as high as they were expected to be. Electrocution. Among construction-related fatalities, electrocution as a cause of accident consistently ranks the number 2 position. These two can be prevented. Consider the following accident. Employee number 1 was working and replacing siding on a house. He was on the aluminum extension ladder up about 35 feet. Lying in the street 20 feet behind him were power lines. After finishing that particular section, employee number 1 descended the ladder, but rather than retract the ladder before moving it, he decided to lift it on his own and carry it the few feet away to the next section. Another employee asked if he needed help, but the help was declined. Mere seconds later, the ladder became too top-heavy and fell back into the power lines. The electricity, always looking for ground, traveled down the ladder and through the worker. He died instantly. In this case, a number of things went wrong. Employee number 1 should never try to move that ladder by himself. There were others there to help him. But even if he was alone for some reason and did not have to move it alone, he should have taken the time to retract the ladder than carrying it horizontally. Never move your ladder in the vertical position, especially if power lines are in the vicinity. You might also ask, as did the investigators, was there a better ladder type to be used, especially considering the proximity to power lines? The answer was and is yes. The workers did, in fact, have access to non-conductive fiberglass ladders. They chose to stick with the conductive aluminum type because they were lightweight and, ironically, easier to move from spot to spot. If you notice that a worker has unknowingly contacted a power line, then call out to him. Try to keep him calm and call for help. But do not approach the worker or ladder until you are positive the power has been turned off. Never attempt to rescue someone who has been shocked and is unconscious. Wait until the lines have been de-energized. Never be fooled into thinking the lines have been de-energized without confirmation from the electric company. Sometimes a breaker will reset itself. Never try to use anything to knock the line away from the ladder. The object can also conduct electricity. In conclusion, ladders, like all equipment, can inflict serious injury or death when misused or abused. Improper training, poor operation, failure to perform preventative maintenance, and failure to inspect can have serious consequences. Safety is the responsibility of everyone involved. When it comes to ladder safety, you can help prevent injury or death by following all safety work practices and safety regulations. Always take the time to inspect your area, your ladder, and the potential hazards around you. When in doubt during any phase of an operation, take the time to stop and consult your employer, the standards, or another available information around you. Good luck and stay safe.